Hey there YouTube, Superbrain AK here, and I have an update video on these modular USB power boards. First thing you can see is I've done some modifications to it. These LEDs used to be blue, now they're green, and I've increased the resistance to some of them. This one, these two red ones, and when I swapped them to green, I increased the resistance too, and also this one used to be blue as well. So, just making it a little bit dimmer because this is going to be sitting right next to my head, next to my bed. So, made sure to dim it down a little bit so it isn't blinding me. And yeah, you can see the different levels here, and I'll post some before and after shots right now. And so you can see those blue lights, they're kind of swamping out everything. So, the after modification picture. Turn the lights off. Insert an image, and you can see that with approximately the same camera settings, it's definitely a lot nicer. So, let's get to the other modifications that I've done. So the next modification that I did is in regards to the standoffs. So, if you look right here, how they used to have them was with the threaded end on the bottom, so you would screw it in from the bottom, and then you would have male posts at the top. And then you would tighten the nut down from the top. So, unfortunately, the boards, especially this combo 6559 and 6550, the components are right next to the standoffs, so the nuts would interfere. So what I did is I just flipped it around. You can see that the nut is much larger than the hex shaft of the standoff, but the screw is approximately the same size as the protrusions of the hex standoff. So, good little tip is to just flip the standoffs around. Now, unfortunately, it doesn't clip right on and stay in place. That's probably why they had it like that. So, flip your standoffs around and you won't have to worry about compatibility issues and using a hex driver to do the nuts. You just need a screwdriver. So the last modification that I did is in regards to the IP6518 dual module here, because somebody forgot to give it a spine. So I'll get it off and show you what that's about. So here is the IP6518 dual board, and you can see I've got some little test points soldered on to the negatives of the capacitors, and I was measuring some voltage drops under a 15 volt 2.5 amp load on each output, so that's about 80 watts, which these are only rated for 45 watts each, so that was a pretty good load. And these are the millivolt measurements. So from 6 to 1, that's number 6 there, so that's the negative of the standoffs, to 1, which is the main input capacitor. we had 65 millivolts of drop. Now I'm not sure what the current is, but it would probably be 5 amps, from these across. And I was powering it from the barrel jack, so not sure what the calculations are for that. But yeah, 65 millivolts. That's pretty high for just a short little circuit board. So, let me insert an image of the back of the module and show you what the problem is. So, the problem is that at the top there, you have the negative, say on the little tab on the left, that has to go around the positive standoff, which connects to the positive rail between the two standoffs. Hopefully you can see that there with all the stitching. And then it has to continue. Now it does bleed into the center ground plane, and then it travels along a tiny edge there at the top all the way to the negative standoff connection point and the USB ports. And I've scoured and scoured, and no, there is no negative connection in the middle between the USB ports and the main ground plane. It isn't very well connected. And the same is true on the bottom, because the positive plane just connects straight through and it's stitched on both sides. It just travels through that tiny little sliver right next to the positive terminal and makes it into the ground plane of one of the modules, and then it slivers up into the center, and then if you can see that trace there from the Q of the QC2 down to the second symbol in the Chinese down there, the upside down Y with the T, that's all some sort of positive. So the ground connection only goes from there, slivering off, all the way to the main negative standoff and the USB ports. So, I'll switch you back to the camera view, and you can see that I gave it a spine because it was a little bit floppy. So, I soldered some 14 gauge solid core copper wire from the negative posts of this USB port and branched it off to that capacitor and branched it off to this capacitor, and I've stitched it to this ground connection, this main ground plane on this side of the positive. I scratched off the copper and soldered it down, and then all the way back to the barrel jack and this connector and the capacitor. And yeah. And I guess I forgot to mention that this capacitor, you would think that it would, connect straight across, but no. It actually connects all the way over here through a tiny little sliver behind these little connection points. So yeah, it was not very good. But a nice solid piece of 14 gauge across, connecting to that, stitched into this ground plane, and then finally on the main backbone. And then I also teed off, connecting to this capacitor, a little bit of Kapton tape on the positive of that capacitor, just to keep the solder from wicking to it. Scratched off the ground plane here, so stitched it together. And then over to here, getting into this capacitor, and then finally back to the USB port, just to bridge this little gap here. and make it all nice and round. So, with those improvements, you can see that the voltage drop has reduced significantly from 65 millivolts from stem to stern to 1.7. That's a significant reduction. And then, yeah, the main voltage drop was literally between here and here. 55 millivolts across these USB ports. So yeah, there was definitely nothing connecting in the center here. So that dropped to 0.2, and 5 to 1 was 11.5, and that has dropped to 1.2. So that is definitely the significant distance, the most significant section, because, you know, well, it's the longest. And yeah, on the top side, it was pretty good on this one, with only 7 millivolts, but now it's down to 0.9, and 4 to 1 is down to 0.9. And the difference between these two was pretty negligible, but now it's literally 0 or 0.4. So, this little module is definitely working significantly better. It's going to be less heat, less voltage drop, higher efficiency, and yeah, overall, just way better. So, if you do have this module, consider giving it a backbone, because they didn't bother to give it one from the factory. So, that's about it for these modules. I've upgraded them pretty well, and I'll have some more stuff going for you guys. Maybe a short talking about that power meter. And I hope you guys enjoyed the video, and I will see you guys in the next one. Thanks for watching.